We are now going to be talking about roots, and we'll start this conversation talking about the roots that most people are familiar with, and that is square roots. So what is a square root? First of all, let's talk about the symbol that we often think of. It is this symbol right here. This symbol also has another name. This is called a radical. So when we use this symbol, we are calling it a radical. So I may say radical, and it refers to that symbol. So square roots. You are going to see questions that are phrased like this. First of all, I'm going to type this out because it's a little bit wordy. Find all real square roots of. I guess it's not as wordy as I thought it was going to be. Find all real square roots of, and then you'll have a number listed. So if I say find all real square roots of, and then I give you the number 25. What that question means is, give me all the numbers that make this statement true. Something times itself is equal to 25. Or what number squared is equal to 25. And instantly, your mind probably goes to the number 5, right? You'd say, oh, 5 would be the square root. 5 times 5 is equal to 25. But there's also another number that makes that true. What is it? Negative 5. Isn't negative 5 squared? If I multiply negative 5 times itself, doesn't that also equal positive 25? It does. So when we say find all real square roots, we are talking about both the positive and the negative version of it. Sometimes we will see this, plus and minus 5. So if I said find all the real square roots of 25, I did that one, 64, you would say that all the real square roots are positive and negative 8. What number times itself equals 64? Okay. If you're ever asked to find all the real square roots of a negative number, negative 9, what number squared is equal to negative 9? And I'll let you think about that for a second, but hopefully what you come up with is that there's no number that when you square it equals a negative number. No number times itself can equal a negative number. So we say that there are none in that case. Okay? Now, I mentioned this symbol earlier, this radical symbol. When we use that symbol and a number inside of it, like 36, when we use that symbol, we are always just referring to the positive root. This is only asking about the positive root. So we would say the square root of 36 is 6. The only way that that would be different is if there is the plus and minus sign out in front of it. Plus and minus, positive and negative square root of 100. So we would say that would be both positive and negative 10. So, but if you see the radical symbol all by itself, that's implying just the positive version. So now let's talk about some of the instructions, some of the words you're going to see. Evaluate. Evaluate always means find the value of. It's right in the middle, right? Find the value of this thing. So when we are evaluating roots of a number, we're going to have a numerical answer. Now, as we just said, whenever we use this symbol all by itself, we are talking about the positive version of that root. But sometimes we could put a negative out front. We might say negative square root of 81. And you would then say, okay, I know that the square root of 81 is 9, but this negative just comes along for the ride, right? Because that was out in front. So that would be negative 9. If we see the radical and we put negative negative 4 in here like this. Pause and think about that. We can't take the square root of a negative number and get a real answer. We can get something called an imaginary number, but that's for another time. So we say that there is none. You might get an error if you try to do that on your calculator. Now we can also evaluate roots of fractions. So we might see the square root of, let me do this a little bit better, the square root of 49 over 36. I need to make my radical a little bit taller. And it's important to know that when you have the radical over a fraction, you can separate it into the square root of the top and the square root of the bottom, right? You can separate that into both parts and take the square root of them individually. So this would turn into the square root of 49 is 7, and on the bottom, the square root of 36 is 6. So there is our answer. So pause and try this one, negative radical 81 over 100. I'll let you ponder that for a moment. I could separate into negative radical 81 over radical 100, which is negative 9 over 10. I can also do this. This one looks a little bit different. The square root of 20 over 45. I want you to pause the video and give this one a shot. I'm going to keep going. So you might look at these numbers and notice that they are not perfect squares. In fact, I think it's helpful exercise for you to do when you're working on these problems to list out all the perfect squares up to maybe 15 or 16. And when it comes time for a test, write these on your paper at the very beginning. So you have the list of these perfect square numbers. 1, 4, 9, 16, 25, and so on, right? So just put a list of these when it comes time for your test, and also even when you're working on your homework. So then you have a list of all of these numbers, and you can get them out of your brain, and you don't have to think about them anymore. I'll stop right there. All of these numbers here are perfect squares, right? The numbers that are answers, that are the result of squaring a number, are called perfect squares. So when we're taking a square root, we're always looking for these numbers, right? 49, 36, 81, 100, those are perfect squares. But what about 20 and 45? Do we see them in this list over here? No, we don't. So you might be wondering, well, what's the deal with this? And maybe you even tried it on your calculator. But what you might notice is that 20 and 45, those have a common factor, right? Those are reducible. You might be looking at that thinking, can I think about 20 as 4 times 5 and 45 as 9 times 5? Can't I cancel a 5 from inside both of those numbers, just like I would any fraction? Absolutely. So we can start by reducing the fraction into the square root of 4 over 9, break it apart even farther into the square root of 4 over the square root of 9, which gives us the result of 2/3. So we can do that sometimes within our fractions as well. So far, we've only been looking at square roots. We can also look at higher order roots. Something to the power of 2, we often call that squaring, right? We say that is squared. If it's to the power of 3, we call it cubed. Anything above that, we just call that a higher order root, 4th power, 5th power, etc. We can take the roots of those things as well. So if I put this, I put the normal radical symbol. Inside I put a number 8, but I put a number right there. I put a 3 right there. That means what number to the third power is equal to 8? What number times the third to the third power is equal to 8? What number times itself 3 times is equal to 8, right? What times what equals 8, where they're all the same number? Hopefully you came up with, that is 2. 2 times 2 times 2 is 8. So the cube root of 8 is equal to 2. We say this is a cube root. When we use the radical symbol all by itself, it's implied that it's the square root. If we want to use a different higher order root, we just put it up in that little notch there. So could we figure out the cube root of 64? Pause for a moment. Now you also might look on your calculator. Some calculators have a function that looks something like this. They might put an X there. And you would start by putting the root that you want to find. You would put a 3 followed by that symbol followed by the number that you want to take the square root of. Often the calculator will put a parenthesis here, and then you can put the number that you want to take the cube root of. Okay, so this is what that would look like. Or maybe you could just think through it, and in either case you should find that as 4. 4 times 4 is 16, times another 4 is 64. What about this one? Cube root of negative 125. Think about that for a moment. I'm going to keep going. Well, your initial thought might be that, hey, you can't take a negative root. Well, we couldn't take a negative square root because squaring any number, whether it's positive or negative, always gives you a positive answer. But that's not true if you cube any number. What happens if you cube a negative number? What happens if you take some negative number to the third power? It's a negative times another negative. That's always going to end up to be a negative answer. So if we took negative 2, for instance, that's negative 2 times negative 2, which is 4, times another negative 2 would be negative 8. So it's okay to take a cube root of a negative number. In this case, it's going to be a negative 5. So that is okay. We could take a fourth root, say of 256. We can do that. Again, it means the same thing. What number times itself 4 times equals 256? You might need a calculator for this. What you should come up with for this, it is 4. 4 times 4 times 4 times 4 is equal to 256. We can also do higher order roots of fractions. See if you can do this one on your own, in your own mind first. I'm going to put a, let's go 64, the cube root of 64 over 27. I'll keep going, but you go ahead and pause it. Just like before, we can separate it. Cube root of 64 over the cube root of 27. We did this one already. The cube root of 64 is 4. And did you figure out what the cube root of 27 is? That's right, it's 3. 3 times 3 is 9, times another 3 is 27. So 4 over 3. And so that is our introduction to working with roots. We saw it's got this symbol called a radical. It implies, the radical by itself implies it's going to be the positive version of the root, though there can also be a negative version if you're asked for it. We can't take the square root of a negative number, but we can of an odd number. So we can't take the square root of an even numbered root, but we can take the odd numbered root of a negative number. We could take radicals of fractions, and we can take higher order roots as well.